finally, I want to go over running a single vehicle or multiple vehicles over a single cycle or multiple cycles, changing some parameters. So the same thing that we just did using Ember, I want to do using MATLAB. So the first thing that I'm going to do is go to my projects folder, session 1, right click on A Startup and run my A Startup. This will initialize my MATLAB, my Ember, and it will set my paths for all my libraries. Then I want to go over to this resource that we have. It's called Ember 2022 Programs Examples Batch Runs. So I'm going to go over a few examples so that you learn how to um, do these processes using MATLAB. I want to start by opening up my example 1 batch simulation runs. I'm going to open it using my MATLAB. After running my A startup, I shouldn't have any issues running or accessing any Ember related files or functions. So the first thing that we're going to do in line 11 is we're going to create an instance of a multi-run. So we're going to call it run vehicles. In this run vehicles, we can also turn on the simulate signal logging. So we set it to true. This is not necessary to do every single run, but it's optional. Then we're also going to create a single run where we're going to add our conventional mid-size CI 5-speed AU.a vehicle file. So I'm going to grab this and I'm going to show you so where this file is located. So in this energy system vehicle systems, this uh, this location is where you'll find all the same vehicles that you are able to access through the tree when you use the GUI. So I'm going to go to this to show you. So you'll have your heavy duty vehicles separated by powertrain. Same thing with light duty. So you'll find all the reference vehicles that you can access through the GUI. So we're going to be using this conventional midsize 5-speed vehicle, and we're going to run it through our UDDS cycle. As you remember, our UDDS or any cycle in Ember will have two files, the map file and the A cycle file. So we'll be sending in the reference of the A cycle file. Then we're going to take this single run and we're going to add it to our run vehicles. And then we're going to run this run. So I'm going to run from line 11 through 16. In this case, it'll build up the model, the Simulink model, and then it'll run the simulation. So you'll see it's creating the models. So I've mentioned in a previous video that we can save simulation time by having a specific model and already built up, saved, and using that model. So instead of having to create the model from scratch, you could just load up the model, which can save up simulation time. So we'll go over that in the session number 2. But in this case, I wanted to show you how the simulation run is done because in previous videos I had just stopped it. But in this case, you can see that the models are built and then you load the Simulink model and then you run the simulations. Okay, after the simulation is done, you can go to your results folder, and this will be the last folder that you have in there. And that is my result. If you're not sure, so for example, we have 5 results in here. If you're not sure which one is your run that you just did, you go into results vehicle dot results, and I'm gonna put a 1 because we have a single run, and it's gonna give me my path. So this is where my results file is saved. I also have this is error, which is very useful. If it's a 0, there's no errors, and this is a 1. there was an error during the simulation run, and the value will usually have that error message. In this case, since there was no errors, there's just a path. You could load up the simulation, the data.mat, to see all the results, or you can also use this line 17 to get the results as a table. So I'm going to run line 17. I'm going to open it up in here. So you have your results as vectable table in here. And I'm going to create the headers for my results table. So I'm going to get my mass, my engine power, and then my fuel economy. This is actually in kilowatts, and I'll explain in a second. So I'm going to run line 19 through 20. And from the results that I got from line 17, I'm going to use this get results numeric formatted. So using numeric formatted will give you the result back as using the user's unit. So I'm going to do the example is using the engine power. So the numeric formatted would be the kilowatts, but if I were to use, get results, I think numeric, I would get it in watts. And also in here, I could select the unit that I want this fuel consumption in. So I'm going to run line 23 to 25. And then I'm going to create a table. This is also kilowatts. And then I'm going to create a table with those three values. So in here, you'll see that table. And then line 31 and 32 is just about saving that table. So this is how you run a single vehicle over a single cycle. Like I mentioned, I'm going to clear my workspace. You can also load up the simulation data. So I can go in here and load up my data. And I also have access to my predefined MATLAB plots. So I can go and engine hot efficiency map, and I can do my torque. So this is the operating points, very similar to how we did it in the GUI. If you want to find more plots, you can go to Amber and then find them by the name and then try to look it up. But you can also go to Amber 2022, libraries, energy systems, vehicle, and then we're going to go to the VPA. And for example, the file that we just used, engine hot efficiency map torque, if you go to the engine folder, plant, and analysis, you'll find all the plots available for the engine component, and you could do similar things with other components. So for example, my battery, I'm going to go to that ESS folder, plant, analysis, and then I'll have this battery discharging map. Plot. So you can do that with all the rest of the components if you're looking for a specific or a predefined MATLAB plot. Next, I want to go to batch example number 2. So I'm going to open it in my MATLAB. I'm going to clear my workspace again. So in this case, we're going to have my UDDS, my highway, my USO6, and my acceleration. So we're always, for example, we have a cycle, and this is a process. So we're always going to use this extension, the A process extension or the A cycle. And I'm going to run a single vehicle, so the same conventional vehicle, over multiple cycles. So I'm going to start by defining my process list from line 8 to 12. So this is my cycle list. I'm gonna create the headers for my table, for my results table. That is from 14 to 17. I'm gonna create again that multi-run. I'm gonna call it run vehicles. And then I'm gonna generate a for loop that is gonna go through all my process files, so through all my cycles and my acceleration process. And then for every cycle or process, I'm gonna create a single run where I add my vehicle and then I add my process name. And then I'm gonna add that single run into my run vehicles. So let me run lines 21 through 25, which is my for loop. And then I'm gonna run. So this will run 1, 2, 3, 4 cycles for this specific vehicle. I'm gonna pause here and I'll come back. After that is done, you can find your results in the last folder created in your results file. So you have the 4 runs. And again, you can run results. Sorry. Run vehicle.results. It's a period. That result. So you'll have those 4 results and then you can get the path, for example, of the third one. So here's your path. There's no errors. And we're gonna use a similar process where I get my results into a table. And then in here, I'm gonna send in this run vehicles unit conversion. So I'm gonna show you what this is. At the top, you'll have your defaults and your users. So if you want it, you could modify some of the user parameters so that when you call the function get results numeric formatted, they are in the units that you want them. So I'm going to get my results, my vehicle mass, my engine power, and my fuel economy. And then I'm going to generate my table. So in here, you'll see that I have my process list, my vehicle mass from line 30, my engine power from line 31, and then my fuel economy from line 32. You can also do the same and load the simulation results individually and do any post-processing that you want to do with that or any plots. Now I want to cover the example number 3 where I run multiple vehicles over multiple cycles. So we have my vehicle list here where I have different powertrains and I have different cycles and processes. So I'll create my multi-run again in line 21. And I'll create this vehicle row and process row for my table. And then I have a double for loop, one that goes through the vehicles and another one that goes through the process. So every vehicle runs through every process. So we have 1, 2, 3, 4 vehicles and 4 runs. So every vehicle is going to run 4 times. And then I'll add the vehicle name into my vehicle row label and then my process name into my process row label. And then I'll create in line 27, we'll create a single run with the vehicle name and the process name. So it's very similar to what we've done, except we are doing this for multiple vehicles. And then we'll run it, get the results as a table, click the values that we want to get and how we want them formatted, and create that table. So I'm going to put a stop here. I'm going to clear my workspace that had the previous simulation runs, and I'm going to hit run, and I'm going to stop right before I create that spreadsheet. I'm going to stop and come back. The simulation runs are done, and I don't want to run line 46 and 47 because I don't want to create that Excel file. So I'm going to stop. I'm going to go back up again here, and you'll see we have those 16 runs, 4 vehicles, 4 cycles. And let's look at our table. So you'll have all the vehicles, the vehicle names, the processes, the vehicle mass, engine, and fuel economy. If you had 16 runs like this and you were loading them separately and you wanted to know what is the vehicle and what is the process, you could load up your data and look at the VPA dot init. That result, oh, sorry. VPA dot init. And in here, you'll have some of the split HEV midsize information on the vehicle. Or you can also go to VPA.result, and that will have your display name and then your cycle name. So that is a different way. Like if you're loading your data from after you run, you have like another post-processing script that you want to run and you want to load your data, but you want to know exactly what file you're loading, you can reference your VPA.results. You'll also have all your signals. So that is it for how to run multiple vehicles over multiple cycles. Finally, I want to go over an example that I created and I will be sharing with you. So in this example, we're going to run a vehicle and we're going to make some changes, some parameter changes, and then we're going to compare those changes at the end of the run. We're also going to be using our example cycle 2 that we imported, and we're going to use this long haul truck. So I'm going to open this file first, and I want to show you in here. I'm going to look up my vehicle.plant.init, and you'll see that my parameter for my mass is overwritten. I also want to check my chassis plan value. So I have my coefficient of drag overwritten, my frontal area overwritten, my body, my cargo. I also have my final drive that's overwritten. And usually we're able to see this in our GUI. But since we are not using the GUI, I just wanted to show you that you can still look up these parameters in the actual text file for the vehicle. So both final drives, final drive.plan and final fd1, so fd.plan and fd2.plan are overwritten to that 3.1316. So what I'm going to do is I'm going to run my vehicle. I'm going to create my multi-run, my multiple vehicle run. So I'm going to run line 3. And I'm going to create a vehicle. So what I mean by this is I'm going to create an object of a vehicle. So I have this string, and I'm going to use this PFX system that create init using file name, which will create an object of a vehicle. And it has so it's a PFX system and it has certain properties. And I'm going to add this vehicle into my single run. So before we were, so for example, what we did in example 1, 2, and 3, we created a single run the way I have it in line 5 and 6. So the same PFX run multiple single, and inside we're submitting the string of the vehicle name and then the string of the process name or the cycle name. In this case, we're gonna submit the object of a vehicle. So this is this 2 lines, line 9 and 8, we'll do the same. 9 line through 7, we'll do the same that line 5 through 6 will do. I just wanted to show you a different way that you can do this. So I'll submit I'll send in the object of the vehicle into the single run, and then I'll use this add cycle or process, and I'll add my cycle name. And then I'll add this single run into my vehicle runs. I have this vehicle object still. So when we open that text file or that a vehicle file, we notice that our vehicle plant, that mass total, was overwritten. So what I'm going to do is I'm going to remove that parameter. So this will not make any changes to the actual a vehicle file, but it'll make changes to the object that we are creating. So I'll remove the overwritten parameter, and I'll add the vehicle into my single run. So let me run. I don't remember what I run, but I'm gonna run all the way to line 13. And in here, I'm gonna use single run change parameter. So this is similar to when we run a vehicle. We use the workflow run a vehicle and we make changes to those parameters. So in this case, I'm gonna change my body mass of my chassis. I'm gonna increase it. So I think the value that we have in this A vehicle file for my body is close to 11,000, and I'm going to increase it to 12,000. And then my cargo mass, I have close to 17,000, so I'm going to increase it again to 19,000 just to get for the example. I'm also going to increase my coefficient of drag to 0.6. So let's say you don't want to go to this file and look, but you can get this vehicle object, and then you can use the method get parameter value all, and then I want to see what my coefficient of drag is, and I put that parameter in parentheses as a string, and it'll tell me that is 0.52, so I'm going to increase that value to 0.6. I'm also going to change my final drives to 4, and I'm going to make all this changes into that single run, and then I'm going to add my process, which is the cycle that we imported. I'm going to run that. I'm going to add that single run to my vehicle runs, and I'm going to run it all. And then at the end, and just this part is just getting those results so that we can do the comparison. So I'm going to clear my workspace real quick, and I'm going to run my whole script, and I'll get back once this is done. Okay, so this is done. So I want to show you the results table. And we have those 2 cycles that we added. And in previous examples, we had used for loops. So you can still use for loops if you wanted to run this differently, or you can simplify it if you just create multiple single runs and just add your cycles and your vehicles and your changes. So you can either do it either way, whatever's easier for that specific simulation study that you're doing. But in this result, we see that without changes, we get this mass, which is once overwritten. Also, the body mass that I had mentioned, close to 11,000. And then the cargo mass. And then if you review the vehicle file, if we were to open it, sorry. So I'm going to open it and I'm going to look for my chas that plant that in it. And you'll see that the same values that I have in my vehicle are the values that I have on my run without changes. But with the changes, it has the values that I submitted, that I put in my single run, but it doesn't make a change into my A vehicle file. So next session we'll go over how to make changes to those A vehicle files and save them and keep those changes. You see that my coefficient of drag also changed in my final drives, and that affected my fuel economy. So with that, I want to finish our first training session. Hopefully next session we can cover the workflows of how to edit and run, which we kind of cover a little bit, but how to edit a vehicle. Hopefully we're we're going to develop our own engine files, and we're going to make some model changes. So thank you all for joining me, and I hope this helped you.